All right. So in 1 hour 30 and 30 marks, we got to, let's look at the first part. It says on figure, draw a symbol of voltmeter connected to measure the potential difference across lamp. So you should know that this is the lamp. Oh, by the way, I need to put it right again. Okay, so this is our lamp, and you should always remember voltmeter is always connected parallel to the lamp, just like that. Then says she adjusts the variable resistor until she obtains the reading on voltmeter and the ammeter scale like this. So these questions are pretty easy because all you need to do is know what value you're looking at. Now, because between 1 and 2, there is one technique that you subtract any 2 and then divide by the number of divisions. So it means that this is 0.1, right? So 0.1 means that this will be 1.5 and 1.6. So the first readings are 1.6. Sorry, this is the voltmeter. And this one is from 0 to 0.2, divide by 10, so it's 0.02. And you can then count it. 0.02, 0.004, 6, 8, 10. So this is 0.1, 0.12, 14, and this somewhere in the middle, by the way. So 1, 2, 1, 4, 1, 6, 1, 8. So this got to be 1, 7 then. So I'm going to write 1.7 here. All right. Now, then he says that you got to use this equation to find both values on the table and record this. So that's pretty easy because all you got to do is V upon I, so 1.6 divided by 1.7. So that is 0.94. Make sure that, because here we have two significant figures, so make sure you write at least two significant figures. You can increase to 3, but don't write so many numbers. Then 0.83 divided by 0.11. This is what? Okay, 7.5. Let me check why. All right, never mind. Okay, so we got this, and then let's move ahead. So you got to complete the table. It's done. Then it says the student thinks that because the same lamp is used throughout the experiment, its resistance is constant. Okay. And he says that state whether the student's result confirm this, justify your answer by referring to the results. Right. Okay, so if we go back to our results, wait a second, ye kya hai? This is not 1.7, this is 0.17. Wait, sorry. Let's do it again. I made a mistake in calculation there. Acha. That would just make it 9.4. All right, if we look at the results, right, so you might see that the first reading and the second reading, they are not exactly close to each other, right? So there is one rule that you need to keep in mind, and I just want to point out here. If this question comes where he wants you to, say compare two values, so in any comparison question, so I'm going to write it so that when you're looking at the video, you can actually look at it again. So in any comparison question, make sure to justify statement if the percentage difference is less than 10%. Now, what do I mean by this? Percentage difference means how much the difference is in percentage between two values. Like, for example, one of our values is 9.4, right? The other value is 7.5. So without even looking, without, just doing anything, you can actually use this formula. I think you've already done it in math as well. So percentage difference is maximum minus minimum divided by maximum. So this is a formula just to calculate the percentage difference. Now what we do is we just need to 9.4 minus 7.5 divided by 9.4. Okay, मैंने फिर से point लगाना 9.4 minus 7.5 divided by 9.4. If you look at it, you multiply by 100%, you'll see that it's about 20% difference. So I would say, if I were you, I would write it in this question that my answer, let me write it in other color. So my answer of percentage difference, yeah, ye na likho, ye likho. My values, yeah, his values are 2, his values have a large difference. So the statement is not correct. All right. Now, then it says that another student says that the resistance lamp filament increases when it gets hot. State giving a reason whether the observation confirms this. Acha, ab you gotta go back and see that when the lamp was bright, of course its resistance was high. When it was dim, its resistance was low. So this student is basically correct. So we'd say, because you just need to state with the reason, so we're going to say yes, when lamp is bright, the resistance is more, right? Now, if you guys have any questions, please let me know before we move to the next question. Right. The next thing we're going to do is, it says a student investigates the reflection of light by a plane mirror. She uses the mirror vertically on a sheet of paper. Fair enough. She uses a pencil to mark the position of a plane mirror with a straight line labeled XY. Okay. She removes the mirror and draws a normal at the center line and labels normal AC. She labels the point at the point where the normal crosses the mirror, letter B. So basically what, if you, we have also done it in class, if you have, a mirror like this, and this is the paper, all right? So this is a 3D sort of thing. So she has first drawn a line, X, Y, and then she has drawn a normal line, which is AC, and where, these two lines intersect, that's B. So this is the 3D figure of whatever they've shown, all right? Now, then they say a ray of light is incident on mirror at B when the angle is 40 degrees. It says draw On figure, draw the line 10 centimeter long from AB to the left of normal to the represent the incident ray. Label the other end of the line D. Now you need to know that the incident angle should be 40. So I don't have any ruler or anything, but I would just, if I were you, I'd just draw a line which is 40 degrees from here, draw an arrow like this, and using my protractor. Then it says that label this line D, so I'm going to write D. And then it says the student replaces the mirror, she places a pin P1 close to P1, and the line DV crosses pin P2. Okay, she views the images of P1 and P2 in the mirror from direction indicated. Right. And she places two pins P3 and P4 on the paper. So P3 and P4 and images of P1 and P2 are viewed by E in a straight line. Okay, fine. So now it says the position P4 and P3 are shown. Draw a line joining P3 and P4. Continue the line until it reaches mirror. So they've already told you what to do next. So I'm gonna use my ruler and I'm gonna draw a line exactly like this so that it just reaches the mirror. That's what they've instructed you to do. Then they say measure the angle of reflection. Now you need to just put your protractor and measure this angle. I don't know what it might be, but whatever it is, it will be close to 40. Not exactly that. You can actually check it using a protractor. Then it says whatever. Let's assume it was 41. Let's now this is just assumption. I don't know. You can do it on your own later on. Then state one precaution that the student should take when positioning the pins to obtain an accurate value of R. Achha, one of the this point that they asked, right? So when you're looking at the pins, right, it is always a good idea to look at the pins at their base. I'll tell you why. Because when, suppose this is like in 3D, if you put a pin like this, and if you put a pin like this, so basically what happens is the pins might be inserted a bit tilted, but you might see that although from an eye's perspective, you might see that this pin is a bit moved because it was like just tilted there. But actually, if you look at the base, they will be very close. So you don't actually look at the tops, you actually look at the base. So if I were you and I was like, uh, if I was, writing this point, I would always say that um, he, okay, the student, sorry, the student should be viewing the pins at their bases when aligning with each other. So this is one point that whenever pins come, do remember to look at from at the base, and that is going to help you a lot. Finally, if you have any questions in this question, please let me know. Okay. Now, moving on to the next part where it says a student measures the least pressure that a rectangular wooden block exerts on a table. He places the wooden block on the sheet of paper with its largest surface touching on the paper. Fine. He uses a pencil to draw the outline of wooden block. Fine. Take the measure of wooden block. Now, in this particular case, you need to first take two things in account, right? First of all, you see, it says nearest to 1 centimeter. So basically, you are actually going to calculate it to uh, 0.1, 0.2, or 0.0, whatever, and then calculate the area of the largest surface. Now, let's suppose you take the length, right, and your answer is exactly 5 centimeters. If you write 5 centimeter here, it would be wrong. The reason is because if they say you have to take it to nearest 0.1 centimeter, it means you have to write 5.0 centimeter. Putting a 0 after this is very essential, because if you don't, it means that you haven't followed the precision of the instrument. So please do remember that. Then width, let's take it 2.5 centimeter. So I'm just going to write 2.5 centimeter. Then you just got to find the area. And the rule that I've already told you is the same, that you just need to take, like, there are two significant figures in this, there are two significant figures in this. So the answer should be either in 2 or 3 significant figures. You could, just play around like that. So I would do 5.0 times 2.5. It is 12.5. So I would write 12.5 centimeters square. Fine. Acha, uske baad next here it says that they have shown a Newton meter. Write down the weight of the block. Up this is you see, wow man, this is like 0 to 1, and we gotta do this. So this is 10, this is 20, 30, 40, 50, 60, 70, 80, 90. So this means 0, this is 0.9, this is 0.1, and this is 0.2. Now, if I were you, I would just subtract these two first and divide by the number of divisions, which are just 10. So actually, each division is 0.01. It means this is 1.1, this is 1.1, 1.2, 1.3, 1.4. So this reading is actually 0.14 newtons. So now I'm gonna write 0.14 newtons, and then says use the equation to calculate the pressure. We have already found out the area, and we have the force. So then pressure equals to force over 12.5. Okay, so I am sort of, I don't know, getting 0.0112. Okay, that's fine. It's actually fine. Okay, then this is the important question. Another student says that the actual pressure due to weight of block on the table is greater than the value calculated. Suggest one practical reason for this. So there could be like number of reasons here, but they say one practical reason. So please don't write that suddenly somebody jumped on it or whatever. You say that because, and we can't say that this is like non-uniform, because they have given us that it is a rectangular block. So if I were you, I would say that the pressure would be larger in actual than we have calculated, because when you trace something, right? So basically, your line does not actually trace the actual length. It is a bit larger than that, because the thickness of the pencil that you use is also there. So if I were you, I would write that the thickness of my pencil, sorry, his pencil, also increased the area when tracing, right? Hence, pressure calculated is smaller than actual pressure. Okay, so please do write this, and there is like, unless you don't practice a lot of papers, you won't be able to get these things. All right. The next, if you have any questions in this one before I start the new one, please let me know. The next is question number 4. And first of all, they say use a pivot 60 and the position of the pivot is not changed during the experiment. So that is something important to read. She places 150 gram mass M. Where is it? Okay. And the center mark is 90. Fine. She places a copper cylinder on the rule and adjusts its position until the rule is just balanced. Very good. And now it says the distance of the left end of the right end, blah, blah, blah. Take your readings on figure 4.2 and record the values. Show your work. In this sort of questions, right, I would suggest that you use your, say, set square. Sorry, I just slipped out of my mind. Now, why a set square is really important? Because if you place the set square just like this, right, and it will be, just against this. So it will really help you get the right reading on this. Okay, one. And you can do the same for the other end. So you can actually place a set square like this. And then just try to get the right reading. Okay. Right now, it is, for me, it is 8.5, right? And I've done it from my just hands. So you might get a different reading. And I think this will be this one, which I believe is 10.2. Okay. So what you then do is you subtract these two. And 10.2 minus 8.5 is just 1.7. And this is centimeters. So make sure that you use set squares. And set squares are one of the best instruments to actually help you get the right reading, which is also 90 degrees. Now, then it says the student repeats the procedure by moving the mass 85, 86, blah, blah, blah. The distance from left end of the meter rule and center is R2. What? Okay. All right. Now, missing value of X and Y. Okay. So the missing value of X and Y, अभी इसको देख लेते हैं. Basically, it's like right here. It's just right here, right? So उन्होंने cylinder आपको दिया है, right? If you second, ये हमने R1 निकाला था ना. What is R1? R1 was a distance from 0 to the center. My God. Hold on a second, my friend. Okay, this is So this is not the, I haven't found R1, I found the difference, sorry. So I gotta find this, I gotta find the center because they say R1 is still the center. I'm sorry. So we gotta do that. Hold on. So this was 8.5, this was 10.2, and we got 1.7. This means the center would have been, one of the ways is that I divide this by 2, right? So let me just show you. So if I divide this reading by 2, 1.7 divided by 2. So this will be 0.85. And then I can add 0.85 to basically 8.5. So I'm going to get exactly the middle position, which is 9.35. Now 9.35, this is 9.1, 9.2, 9.3, somewhere here. This is exactly middle that I was looking. So basically what I did was I took the difference between these two, which I got 1.7. Then I divided by 2. So basically I got exactly half of the difference. Then I added it in this to get exactly which point is the center. So let's take it just 9.4. Now let's put it here. Centimeters, very important. And now it says R1, you need to fill it in. So this was 9.4. And it says X is 60 minus R1. Fine. So 60 minus 9.4 is 50.6 centimeter, and 90, sorry, R2 is 90. So 90 minus 60 basically is 30. Now the answer is 30, but if you look at it, the precision is 0.1. So I will also complete it by writing 30.0. So make sure that you follow the precision of the table, otherwise you won't get any marks for this. Remember that. Now, then it says that this is the graph, and I believe they say, oh, they haven't told us to draw the graph. So it says record on the grid plot Y on y-axis, x on x-axis. So first we're going to write x and y, and then we're going to check which units they are. So both are in centimeters, so I'm going to write centimeter. I'm going to write centimeter. And the graph is starting from 0 and 0. So we'll do that. Please don't shorten it up. Now make sure that most of the graph is used. Ideally, 50% of the area given should be used. So we are going to do it one by one. So first is 50.6 and 30.0. And like on the x-axis, you got to go till 50 somehow. Okay, so I'm gonna do 10. I'm gonna try 20, 30, 40, 50. I think it will do. All right. And then this one is, it should be from 10 to 30. So the maximum value we got to go is 30. If I were you, I'd just leave 2 positions. So 10, 20, 30. Now this way, it will actually help me cover a lot of area. If I had just gone through, you see, like 10 and, sorry, 10, 20, 30. So then my area would just be this much. So don't make that mistake, please. Okay, then let's try to plot some points, right? I don't know. It says start your axis, draw. So we have to start from 0, 0, and we have to draw a straight line of best fit. So, right. So quickly do this. 50.6 and 30.0. First one is X. 50.6. So I think this is 51, right? So it should be somewhere in the middle. And 30.0. So I'm putting a small dot and then a circle around it just to know that I have placed my point here. Then the next one is 37.8 and 25. 35, 36, 37.8. So right here. And 25. This could be 25. Somewhere, I believe here, like this. And 28.1 and 20. So I guess 25, 26, 27, 28, and 20. I think 28 and 20 would be here. And then 16 and 15. 16.4. 15, 16, somewhere in the middle. And 15. Somewhere here. Do not color it, please. And then 4.7 and 10. 5, it's almost here. And somewhere like pretty close to the line, somewhere. Okay. Now, if you look at it, the condition is, as you can see, that we got 5 points. And we must, okay, and we need to draw a line of best fit. So, fine. So it means that we gotta do wait a second. Little bit adjustment is required. This is not correct. You got to make some tries unless this doesn't fit, okay? Okay. Now, just a bit down from here, just a bit up from here. Okay, we still haven't reached the sweet spot. Okay. Now, if you look at this line that I've drawn, you might realize that it does not passes from all points. It is not necessary to make sure that it passes from all points. What you got to do is, line of best fit means that equally the points are divided on top and bottom. One of the most important things is this. If you look at it, it is crossing from this point. So let me use the different color. It crosses from this point, but this point and this point are below, and this point and this point are above. So it means that I have created that balance, which makes this line line of best fit. It is not necessary that you cross it from maximum number of points. That is a wrong conclusion. I hope that's right. Then it says determine the gradient of your line and indicate on the graph. Now, how do you indicate gradient? First of all, the rule of the gradient is that you always take the gradient points on the line. I'm writing it. Take gradient points on the line, number one. All right. So, and the second rule is that the points that you take must be like 50% away from each other. On the line. Okay. So this is the rule. Now, to make things easier for me, I would pick a point that suits me the best. So let's pick, say, this point. Okay, so I'm going to circle it. And the other point far away from this, which I believe could be this one. We'll pick this. Now, how do you indicate these points is that you make dotted lines? The dotted lines basically tell you that, okay, it tells the examiner that, okay, you have taken these points on your line for the gradient. And this will be this point and this point. So you make it like this or make a triangle, whatever you want to. Now let's write these points on the line. Let me just remove the extra clutter. Oh my God, wait. Okay. Now, as far as I can see, if this is like 35, so this will be 32.5. Okay, so one of our points are on this one. It is 32.5, comma, and the x one is 55. Take 55. So this is 1 point. And remember, you can write it on the graph area. It's a good thing to do. And here the point would be 11. And this point will be 10.25. So we got this, right? Now, keeping that in mind, we're going to find the gradient. And gradient's formula, if you don't remember, this is y2 minus y1, x2 minus x1, and it could be the rise over run as well, whatever you like. So 32.5 minus 10.25 divided by 55 minus 11. Let's do that. 32.5 minus 10.5 divided by 55 minus 12. So my answer is exactly 0.5. Now to write 0.5 is a bad idea because you would ideally want to basically write it in 2 to 3 significant figures. So I'm going to write 0.50 as my answer. Now, sometimes you will also have units. In this, there are no units because you had the same units on both sides, so they cancel out. But if they're not, then you also need to check the units. Now, it says the mass in grams copper is gradient this. Use the equation to measure the nearest this. Okay, fine. So I'm going to do 150 times 0.5. This is 75. Now, because they say find the nearest gram, so 75 grams would be the nearest one. You don't need to put a point here. Please don't do that. Now, okay. If you guys have any questions in the graph or what I've done, please let me know. So moving on to the part C, it says blah, 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 and blah, blah, blah. You already know this. It says calculate the volume V of the copper cylinder. One of the most important things that you got to do is you always need to take the readings from the lower meniscus or whatever the curved part is, right? So this is the reading, not this one. So don't make that mistake, okay? If I check this reading, this will be, where is it? So 10 divisions from 50 to 60, which means 51, 52, 53, 54, 55, 56, 57. Stop it here. Okay. Now this will be 57. My bad. And then it says calculate the density of the copper using your answer in this and this. So we already have the mass, which is, I think, what did we get? Second, please, 75 grams. They also, I think, wrote the units fine. So 75 divided by 57. So I'm writing 5.7 all the time. So I'm getting a density of 1.32. You can round it off. And then it says the value of the density of copper obtained in a differs slightly from the correct value. State one practical reason for this. It says it's slightly different. There could be so many things. One of the most important things is that there are a couple of errors that you need to check. Number one of the errors that might be here, like, my answer was 9.3, 9.375, something like that, right? But I had to round it because I don't have any other reading here, right? So when I'm looking at it through say ruler, so the ruler accuracy is just 0.1 centimeter. So you can't write 9.375, right? So this could be one error that, okay, the center or the mass was not very accurate, the position of center mass. Then one of the errors that I found to be important was Beta, please turn off your microphone. Now, the thing is, the other reason is that if you look at it, the although the reading is like exactly on this, but here it is, this whole thing is accurate to 1 centimeter cube only. So we could also write that this measuring cylinder has less precision, right? So if I were you, it would make more sense to write that the precision of measuring cylinder is 1 centimeter cube only, or I would write that difficult to find accurate center of gravity on the rule. So this could be two reasons that you could write. If you still have any questions, please let me know. Yes, please. Okay. Acha, one last thing that I got to do before I go. That is, I would also like to discuss in case if there is a curve, right? So the curve question we were doing already, I think we sort of made that. So I gotta find it. Wait a second. Yes, we did it. Sorry, you were. So इसी में से हम करेंगे. Some people who missed, you can actually check it out. So in this question, they had similarly given us the table, and we just needed to draw this. But the only difference is that they wanted us to draw smooth curve of best fit, and they said that, okay, start both axes from this side. So the smooth curve would be if I just draw it such a way that it is not necessary to join all points. All right. Again, I'm telling you this. It is not necessary that you join all points, but it is very important that it should be a smooth line and should divide points equally above and below. Primary verb like this. Okay, so if you look at it, my points, basically this is almost on the line, so I should have done it even better. This is on top. My God. So you can just do it one or more try. This is on top, this is on bottom, this is on top, this is on bottom. So my points are equally divided and it should be a very smooth line. Acha, one of the tips that I want to give you is that if you go to a bookstore and make sure that you get this ruler. It is called, it's a rubber sort of a ruler that can bend. It can bend like this, it can bend like this, right? It's made from rubbery material, right? I don't know what it is called, but what it helps is that basically it can, because it is also transparent, make sure it's transparent. And when you just press it to this, so it can actually help you make smooth curves a lot of times. So I think it would be nice if you do that. Okay. If you have any other questions regarding this or anything else, please let me know. Otherwise, this paper is quite simple. You just need to follow instructions. And the only reason why I want you to practice a bit, because certain reasoning like the the things where they asked us where the errors might be, right, or would make something inaccurate. Those things only come from practice. So you guys got to do at least like 2, 3, 4 years paper. We have already done till 18. So if you want to practice them again, you can do it and recheck. And if you want to do it like the later ones, you can also try that. All right, then. I guess that is it for today. But first of all, I got to take your attendance. All right, I have taken the attendance. I will also post